Anaximander, Part 2, Cosmology. Anaximander's bold use of non mythological explanatory hypotheses considerably distinguishes him from previous cosmology writers such as Hesiod. It confirms that pre Socratic philosophers were making an early effort to demystify physical processes. His major contribution to history was writing the oldest prose document about the universe and the origins of life. For this, he is often called the father of cosmology and founder of astronomy. However, Pseudo Plutarch states that he still viewed celestial bodies as deities. Anaximander was the first to conceive a mechanical model of the world. In his model, the earth floats very still in the center of the infinite, not supported by anything. It remains in the same place because of its indifference, a point of view that Aristotle considered ingenious, but false, in On the Heavens. Its curious shape is that of a cylinder, a column of stone. Aetius reports in the Fide the third 7-1, or similar to a pillar-shaped stone, Pseudo Plutarch 310, with a height one-third of its diameter. The flat top forms the inhabited world, which is surrounded by a circular oceanic mass. Anaximander's realization that the earth floats free without failing and does not need to be resting on something has been indicated by many as the first cosmological revolution and the starting point of scientific thinking. Karl Popper calls this idea one of the boldest, most revolutionary, and most portentous ideas in the whole history of human thinking. Such a model allowed the concept that celestial bodies could pass under the earth, opening the way to Greek astronomy. At the origin, after the separation of hot and cold, a ball of flame appeared that surrounded Earth like bark on a tree. This ball broke apart to form the rest of the universe. It resembled a system of hollow concentric wheels, filled with fire, with rims pierced by holes like those of a flute. Consequently, the sun was the fire that one could see through a hole the same size as the earth on the farthest wheel, and an eclipse corresponded with the occlusion of that hole. The diameter of the solar wheel was 27 times that of the earth, or 28, depending on the sources, and the lunar wheel, whose fire was less intense, 18 or 19 times. Its hole could change shape, thus explaining lunar phases. The stars and the planets located closer followed the same model. Anaximander was the first astronomer to consider the sun as a huge mass, and consequently to realize how far from Earth it might be, and the first to present a system where the celestial bodies turned at different distances. Furthermore, according to Diogenes Laertius II, he built a celestial sphere. This invention undoubtedly made him the first to realize the obliquity of the zodiac, as the Roman philosopher Pliny the Elder reports in Natural History 2:8. It is a little early to use the term ecliptic, but his knowledge and work on astronomy confirmed that he must have observed the inclination of the celestial sphere in relation to the plane of the earth to explain the seasons. The doxographer and theologian Aetius attributes to Pythagoras the exact measurement of the obliquity. Multiple worlds. According to Simplicius, Anaximander already speculated on the plurality of worlds, similar to atomist Leucippus and Democritus, and later philosophers Epicurus. These thinkers supposed that worlds appeared and disappeared for a while, and that some were born when others perished. They claimed that this movement was eternal, for without movement there can be no generation, no destruction. In addition to Simplicius, Hippolytus reports Anaximander's claim that from the infinite comes the principle of beings, which themselves come from the heavens and the world. Several doxographers use the plural when this philosopher is referring to the worlds within, which are often infinite in quantity. Cicero writes that he attributes different gods to the countless worlds. This theory places Anaximander close to the atomists and the Epicureans, who more than a century later also claimed that an infinity of worlds appeared and disappeared. In the timeline of the Greek history of thought, some thinkers conceptualized a single world: Plato, Aristotle, Anaxagoras, and Archelaus. while others instead speculated on the existence of a series of worlds, continuous or non-continuous, Anaximenes, Heraclitus, Empedocles, and Diogenes, meteorological phenomena. Anaximander attributed some phenomena, such as thunder and lightning, to the intervention of elements rather than to divine causes. In his system, thunder results from the shock of clouds hitting each other. The loudness of the sound is proportionate with that of the shock. Thunder without lightning is the result of the wind being too weak to emit any flame, but strong enough to produce a sound. A flash of lightning without thunder is a jolt of the air that disperses and falls, allowing a less active fire to break free. Thunderbolts are the result of a thicker and more violent airflow. He saw the sea as a remnant of the mass of humidity that once a part of that mass evaporated under the sun's action, thus causing the winds and even the rotation of the celestial bodies, which he believed were attracted to places where water is more abundant. He explained rain as a product of the humidity pumped up from earth by the sun. For him, the earth was slowly drying up, and water only remained in the deepest regions, which someday would go dry as well, according to Aristotle's meteorology. Democritus also shared this opinion. Origin of humankind. Anaximander speculated about the beginnings and origin of animal life and that humans came from other animals and waters. According to his evolutionary theory, animals sprang out of the sea long ago, born trapped in a spiny bark, but as they got older, the bark would dry up, and animals would be able to break it. As the early humidity evaporated, dry land emerged, and in time humankind had to adapt. The 3rd century Roman writer Censorinus reports Anaximander of Miletus considered that from warmed up water and earth emerged either fish or entirely fish like animals. Inside these animals, men took form and embryos were held prisoners until puberty. Only then, after these animals burst open, could men and women come out, now able to feed themselves. Anaximander put forward the idea that humans had to spend part of this transition inside the mouths of big fish to protect themselves from the Earth's climate until they could come out in open air and lose their scales. He thought that considering humans' extended infancy, we could not have survived in the primeval world in the same manner we do presently. Other accomplishments: cartography. Both Strabo and Agathemerus, later Greek geographers, claimed that according to the geographer Eratosthenes, Anaximander was the first to publish a map of the world. The map probably inspired the Greek historian Hesetus of Miletus to draw a more accurate version. Strabo viewed both as the first geographers after Homer. Maps were produced in ancient times, also notably in Egypt, Lydia, the Middle East, and Babylon. Only some small examples survived until today. The unique example of a world map comes from late Babylonian tablet BM 92687, later than 9th century BC, but is based probably on a much older map. These maps indicated directions, roads, towns, borders, and geological features. Anaximander's innovation was to present the entire inhabited land known to the ancient Greeks. Such an accomplishment is more significant than it at first appears. Anaximander most likely drew this map for 3 reasons. First, it could be used to improve navigation and trade between Miletus colonies and other colonies around the Mediterranean Sea and the Black Sea. Second, Thales would probably have found it easier to convince the Ionian city states to join in a federation in order to push the Median threat away if he possessed such a tool. Finally, the philosophical idea of a global representation of the world simply for the sake of knowledge was reason enough to design one. Surely aware of the sea's convexity, he may have designed his map on a slightly rounded metal surface. The center or navel of the world, Omphalo's guess, could have been Delhi, but is more likely in Anaximander's time to have been located near Miletus. The Aegean Sea was near the map's center and enclosed by 3 continents themselves, located in the middle of the ocean and isolated like islands by sea and rivers. Europe was bordered on the south by the Mediterranean Sea and was separated from Asia by the Black Sea, the Lake Maeotis, and further east, either by the Phasis River, now called the Rioni in Georgia, or the Tanais. The Nile flowed south into the ocean, separating Libya, which was the name for the part of the then known African continent, from Asia. Gnomon. The Suda relates that Anaximander explained some basic notions of geometry. It also mentions his interest in the measurement of time and associates him with the introduction in Greece of the gnomon in Lacedaemon. He participated in the construction, or at least in the adjustments, of sundials to indicate solstices and equinoxes. Indeed, a gnomon required adjustments from a place to another because of the difference in latitude. In his time, the gnomon was simply a vertical pillar or rod mounted on a horizontal plane. The position of its shadow on the plane indicated the time of day. As it moves through its apparent course, the sun draws a curve with the tip of the projected shadow, which is shortest at noon. When pointing due south, the variation in the tip's position at noon indicates the solar time and the seasons. The shadow is longest on the winter solstice and shortest in the summer solstice. The invention of the gnomon itself cannot be attributed to Anaximander because its use, as well as the division of days into 12 parts, came from the Babylonians. It is they, according to Herodotus' Histories 2109, who gave the Greek start of time measurement. It is likely that he was not the first to determine the solstices because no calculation is necessary. On the other hand, equinoxes do not correspond to the middle point between the positions during solstices, as the Babylonians thought, as the Suda seems to suggest. It is very likely that with his knowledge of geometry, he became the first Greek to accurately determine the equinoxes. Prediction of an earthquake. In his philosophical work De Divinatione, I 50 112, Cicero states that Anaximander convinced the inhabitants of Lacedaemon to abandon their city and spend the night in the country with their weapons because an earthquake was near. The city collapsed when the top of the Taygetus split like the stern of a ship. Pliny the Elder also mentions this anecdote. 281, suggesting that it came from an admirable inspiration, as opposed to Cicero, who did not associate the prediction with divination. Interpretation. Bertrand Russell, in the History of Western Philosophy, interprets Anaximander's theories as an assertion of the necessity of an appropriate balance between earth, fire, and water, all of which may be independently seeking to aggrandize their proportions relative to the others. Anaximander seems to express his belief that the natural order ensures balance among these elements. That there was fire, ashes, earth now exist. His Greek peers echoed this sentiment with their belief in natural boundaries beyond which not even the gods could operate. Friedrich Nietzsche, in philosophy in the tragic age of the Greeks, claimed that Anaximander was a pessimist who asserted that the primal being of the world was a state of indefiniteness. In accordance with this, anything definite has to eventually pass back into the indefinites. In other words, Anaximander viewed all coming to be as though it were an illegitimate emancipation from eternal being, a wrong for which destruction is the only penance. The world of individual objects in this way of thinking has no worth and should perish. Martin Heidegger lectured extensively on Anaximander and delivered a lecture entitled Anaximander's Saying, which was subsequently included in Off the Beaten Track. The lecture examines the ontological difference and the oblivion of being or destiny in the context of the Anaximander fragment. Heidegger's lecture is, in turn, an important influence on the French philosopher Jacques Derrida. Works. According to the Suda, on nature, rotation of the earth, on fixed stars, the celestial sphere.